All right, let's take a look at some of these limit problems for trig functions. And for all the problems in this part of the homework, we need to use this limit law on the right-hand side. And it states that the limit, as theta goes to 0, of sine theta over theta equals to 1. So what we need to do is we need to make sure that whatever's inside the sine function, that must match the denominator. And when we take the limit as theta goes to 0, the answer will always be 1. So we're going to use this limit law to help us solve some of the homework problems in this particular section here. Okay, so let's go ahead and write out the limit statement here. So the limit as x goes to 0, and the sine 3x, there's nothing we can do about the sine 3x, so let's go ahead and write out the sine 3x. And in this case, there's only a single x, so I'll put that on the bottom there. And I noticed that there's a sine 3x here, right? So 3x is inside the sine function. So that means I need a 3x down there. All right, well, there's an x there already. So what I can do is I can divide by 3 by putting a 3 in the denominator. And if I want to undo that, I can multiply the function by 3. Okay, so if I manually put a 3 there by dividing by 3, I need to undo that by multiplying the whole function by 3. And that will mathematically keep the problem the same. Okay, so now what we've done now is we know that this part right here matches up with this limit law. So sine of anything over anything equals to 1. So we know that this limit equals to 1, and then we can multiply by 3, and that gives us a final answer of 3 there. So there's your answer for question number 1. Okay, let's move on to question number 2. And for question number 2, once again, I need to use this limit law right here. And what we're going to do is we're going to start off by writing out the limit statement over here as x goes to 0. And I have a sine 2x on the numerator, so let's go ahead and write sine 2x divided by, all right, so now I have a 3x, so I'm going to slightly write this in a different way. I'm going to put the x down there, and then I'm going to put a multiplication sign there, and then I'm going to put the 3 over there. So I'm simply going to rearrange the 3x. So the 3 is right there, and the x is right there. I'm just going to rearrange this this particular problem here. Okay. All right, so basically, if there's a sine of 2x, there's a 2x inside the sine function, I must have a 2x on the bottom, right? So the bottom just has an x right now. I can divide by 2 by writing a 2 like that. And if I divide by 2, mathematically, I can undo that by multiplying the function by 2, right? And that's mathematically the same as the original question. So, but if I use this limit law, I know that limit is going to equal to 1. And then I multiply that by 2/3. And 1 times 2/3 is going to be 2/3. Okay, so once again, I'm using this limit law right there. And this is really like an algebra exercise, if anything. Okay, let's move on to question number 3 here. So once again, I'm using that limit law in red on the right-hand side. And let's go ahead and write out this limit statement here for the problem. The limit as theta goes to 0. The numerator is sine 4 theta. So let me write sine 4 theta. You can't change the numerator. Divided by. Okay, and then the theta right here, I'm going to write that as a single theta there. And then with my green marker, this 6, I'm going to just write that over here as a separate fraction, right? So that 6 is over there, and this theta is right there. Okay. All right, so we're just going to rewrite the problem like that. And if there's a 4 theta there, I must have a 4 theta over here to follow the limit law. So I can divide by 4 by putting a 4 there. And to undo, a division statement of 4, I need to multiply the problem by 4. And then once again, we have this limit law right here, sine of 4 theta over 4 theta. As theta approaches 0, that's going to be 1. So 1 times 4 over 6 is going to be 4 over 6, but that's going to be 2/3. Okay. All right, let's move on to question number 4. So question number 4, now we have tan, but the tan function pretty much follows the same identity as sine theta over theta equals to 1. So basically it's the same problem, we just have tan instead of sine, but the technique is still the same. I have tan 2x, so I'll write tan 2x on the numerator, and on the denominator I'll write the single x. Now since there's a 2x here, I must have a 2 here, so that's technically we're dividing by 2, and to undo that I need to multiply the function by 2. And then this part right here equals to 1 times the 2, and that gives me 2, right? All right, let's move on to question number 5. All right, so now I have tan of 3x, so let me write the limit statement as the limit as x goes to 0. Tan 3x, so I can't change that, so the tan 3x is on the numerator, divided by, okay, there's an x here, so that x I'll write out like that. And then I have a 2, and that 2 I will write as a single 2 out here, right? So this blue 2 is really this 2 right there. Okay, so it's always good to kind of rewrite the denominator and kind of split this up into like 2 different kind of fractions in a way. And then you'll notice that there's a 3x here, so I need a 3x there. So I need to divide by 3 by putting a 3 on the denominator. And to undo that, I need to multiply by 3 now. Okay, so this part right here is equal to 1, and 1 times 3 over 2 is 3 over 2. Okay, let's move on to question number 6 now. All right, another limit problem with the trig function there. So limit as x goes to 0. Now the sine 2x I can leave alone. Now on the denominator here, I guess I can factor out an x. So x times x plus 3. Okay, and then what we're going to do is we're going to just kind of split up this this problem here as sine 2x divided by, all right, I'm going to put the x over here, and then I'll put a 1 there and divided by x plus 3 in brackets. Okay, so we're going to split up that fraction. And once again, there's a 2x here, so that means we must have a 2x there, so we need to divide by 2. So if I divide by 2, I can undo that by multiplying by 2. Okay. And if I just have to write one more limit statement here, sometimes you don't have to do this, but I'll just do this for completeness here. So this is sine 2x over 2x. Basically, this limit sign is going to multiply onto that and to that now. And then I'll multiply that by the limit as x goes to 0. And then 2 times 1 is going to be 2, right? So this will be 2 over x plus 3. Okay. We definitely know that this limit right here is equal to 1. So 1 times. And then for the next one here, we can just do a direct substitution there. So 0 plus 3 is going to be 3. So this limit right here is going to be 2 divided by 3. So 1 times 2/3 is going to be 2/3. Okay, let's move on to the last 3 questions here. Okay, so now we have these cubic functions here. So the limit as x goes to 0. Now, if you expand the numerator, that's the same thing as sine 2x times sine of 2x times sine of 2x. And then we have 3 x's on the denominator. X cubed means x times x times x. So x times x times x. Okay, so I have a 2x there, so that means I need a 2x there, so I need to divide by 2. If I divide by 2, I can undo that by multiplying by 2. And then I have a 2x over here, so that means I must have a 2x over here, so I can divide by 2 by having a 2 on the denominator. And to undo division, I need to multiply by 2. Then finally over here, I have a 2x over here, so I must have a 2x over here. So if I put a 2 here, if I divide by 2 by placing a 2 on the denominator, I can undo that by multiplying by 2. Okay, so if you distribute the limit sign onto all 3 of these, we know each of these will be 1. So 1 times 1 times 1. And then we have all of this, 2 times 2 times 2 is going to be 8, right? So my final answer is going to be 8. And that's it for question number 7. And I suspect for question number 8, we'll do the same thing. So the limit as x goes to 0. Okay, there's a tan cubed of 3x. Let's write down, let's expand that. So tan 3x times tan 3x times tan 3x. All right, and then there's x cubed. All right, so that's going to be x times x times x. And then we have an 8, right? So maybe we can park that at the very end, 1 over 8. So that 8, let's just park it over there. And this isn't the only way, this is not the only way you can do these kind of problems. I just kind of like to split things up and expand things. So if there's a 3x there, we must have 3 x's on the denominator. So if I divide by 3, that means I need to multiply by 3. If I divide by 3 here, I need to multiply by 3. And finally, if I divide by 3, I need to multiply by 3, right? All right, so let's go ahead and figure this out. So all these limit statements here, if you compute the limits of those will be 1 times 1 times 1. And I have this 1 over 8 now, and then 3 times 3 times 3 is going to be 27. So final answer is going to be 27 over 8. Okay, let's move on to the last one here. Sine cubed x over x squared. So yeah, we might have to expand this as well. So I'll expand the numerator as sine x times sine x times sine x. And then there's an x squared there, so just 2 x's now. Okay, so it turns out that these expressions here, as the limit goes to 0, will be 1 times 1. And then if I distribute that over there, that's almost the same thing as the limit as x goes to 0 of just sine x. All right, so we have, 1 times 1 will be 1. And if I go ahead and do a direct substitution here, sine of 0 is going to be 0, right? So 1 times 0 is going to be 0. Okay, so that concludes this homework video guide for limits of trig functions.